Okay? And then what else do we need to know?
And then spacing between the lines.
Okay. And how much do we need?
18, right? I don't know.
I think it is 18.
So it gives you a range there, right? It says like 18 to 24. I always go with a smaller number just because the math tends to be easier in my mind for what I'm doing, okay? And I'll show you some, so let me do this. So we're gonna go 0.4, 18 by 18, okay? So we're gonna have an emitter 0.4, we're gonna have an emitter every 18 inches in our tubing, and we're gonna have our spacing on our tubing every 18 inches, okay? So we specified the product, right? Yeah.
With a smaller row spacing though, aren't you going to be using more materials at that point? I mean, you have additional rows if they're closer together.
So you mean 18 versus 24?
Yeah.
Yeah. We'll have a little bit more product in there, but I'll tell you right now, in the landscape, and I don't know why this is, but people don't want, I never hardly get anyone ever wanting to put the tubing more than 18 inches apart. It doesn't bother me at all. It's just the industry. Contractors don't want to put the tubing farther than 18 inches apart. They just get, for whatever reason, they're nervous, and it's crazy. 24 inches is fine with me, but you know.
It just seems like something you'd want to decide based on what you're planting, I guess.
Oh, I see what you're saying. So you're saying,
why spend money on more product when you don't need all that product when you can
based on the planting design?
Yeah.
Okay, so that's a great question. So you know, we're looking at, we haven't even looked at our planting design on this area that we looked at. As landscape architects, what do we typically do with a median like this? What's that? I mean, it's shrub beds. Let's, because we determined it's shrubs, right? How are we going to design our shrub beds typically? We're going to typically, not always, we're typically going to design these to where the plants within 4 or 5 years are going to pretty much cover the entire area, right? When we look at our landscape designs, the majority of our planting beds, when we design them, at some point in the future are going to be covered with plant material, typically. Not always, but typically. And so when we have that, if we put a plant in here and we know that in the future it's going to cover that entire area, that our roots are going to be doing the exact same thing. So we want to be irrigating not only where the plants are at today, but where they're going to be at in the future. So some people will look at that and say, okay, you're wasting water. But in reality, is what we're doing is we're encouraging those roots to grow out where they're going to get sooner or later. And we're encouraging those roots to establish much quicker than by not irrigating. That's one of the challenges with the point source emitters, is that they're putting water right where they're at today and not where the roots are going to be at in 4 or 5 years. And we know that and some people say, well, in 4 or 5 years we're going to come back in and add emitters and as the plant grows. It never happens. I've yet to see it happen. And so if we irrigate for it now, is what's going to happen is, as an example, point source versus those contractors who have installed point source in a median and then you started using inline tubing and irrigating, the plants grow much faster, fill in the shrub bed much faster, and they actually get to where they shut the irrigation system off because the plants can establish themselves, are already established. They can shut the irrigation off much sooner than they can with other devices because we've got the plant bigger and healthier. Does that make sense? That was kind of your question. If we're in Tucson, Arizona, 300 by 10, they're going to have 4 plants in that whole median. It's just the way it is. We don't have any people from Arizona in here, do we? You won't admit it now that I said that, right? So it is. So if we had 3 or 4 plants in here, then we're going to be designing point source, okay? But typically it's going to be covered entirely. Good question. Okay, so 0.4, 18 by 18. What do we need to do next? The ultimate goal here is, we need to know a couple of things. We need to know what product and what spacing in here is, but we need to know what the total GPM of that bed is going to be. We need to figure that out. That's step number 1 after we do that, because we need to figure out if we're going to have how many zones that we're going to have. So in order to figure out how much GPM is, we need to figure out how much tubing we have based on this criteria right here, okay? So 0.67 is a number that you want to get familiar with drip, because we do a lot of 18-inch spacing, and when we multiply things times 0.67, it starts helping us figure out, it's almost the magic number. So we need to figure out what our total square footage is in this area. It's 10 by 300. So what's our total square footage in that area?
3,000.
3,000. And our tubing is going to be every 18 inches. So I know, remember that one chart that I said that all that math figuring out how much tubing was in an area, and we weren't having a math class today? We're still not going to have a math class today. So this is where, when you have that app, it figures all of this stuff out for you really, really quickly, okay? And we'll put it to the test here in a minute. So if we have 3,000 square feet, if our tubing was going to be every 12 inches in that area, the square footage is how much tubing we're going to need in that shrub bed. So if we were going to put our tubing every 12 inches in there, we were going to need 3,000 feet of tubing. That's a shortcut for you really quick. If your tubing is going to be every 18 inches, we take that 3,000 times 0.67, and that will tell us how much tubing that we need. So how much tubing do we need? Smartphones, you can use smartphones. This isn't a test yet.
Isn't that just 2,000-ish?
2010, yeah.
2,000. Okay. So we have 2,000 feet of tubing, right? Okay. So now we know how much product we have. Do we know what our total flow is yet? No. So in this tubing, how far are the emitters apart in there? 18 inches. So what do we need to do to that 2,000? Because we need to know how many emitters, is what we're trying to do is figure out how many emitters are on this zone so that we can figure out our flow rate. Okay? So we have 2,000 feet of tubing.
I don't understand why. What? So you need to know how many holes you have in your line
Tubing.
so you can figure out your flow rate.
Because each one of them is putting out 0.4.
Oh, right.
Right?
Yeah. Okay.
So we take 2,000 times 0.67. What's that number? 16? What is that? 15? I don't know.
13.
Okay, I left my glasses in the hotel room this morning, so I can't see from here in. So if I really screw this up, I apologize.
1,340.
What was that?
1,340.
Okay, so we have 1,340 emitters, right? And it's at 0.4, so we take 1,340 times 0.4.
536.
Gallons per hour. So we divide that by 60 to convert it to gallons by minute, and we're done.
8.9. Close.
So we know that to irrigate 300 feet long by 10 feet wide, we're using roughly 9 gallons a minute. Okay? If we were using spray heads, this number would be about 45 gallons a minute. Okay? You have a question?
Well, I'm just wondering, how do we, like,
I can see that.
figure out the water requirement for that shrub exactly? You know, so like,
We don't care about that.
okay.
We're landscape architects. We don't care about that, do we?
I don't know. I was just thinking maybe someone in here would.
Okay. So in that chart, page 8, we went with loam soil, right? And we went with a 0.4, 18 by 18. If we go down below that, there's a column that says application rate.
Yeah.
And it gives you a number in a decimal, like point something, 0.3, 0.4 something.
There's
What?
a lot of them.
Well, it's right under the 18.
Oh,
0.29? Okay. So basically, to answer your question, without doing any of this other calculation, as soon as we did this right here, we know that we're putting down, if we turn our controller on and we run it for 1 hour, it's going to put down 0.29 inches of water in an hour. Okay? And what does that mean? It means that if we run it for an hour and it didn't run into the soil, it would basically be 1/3 of an inch of water that would be applied, that depth. Okay? We know here in Utah, typically, these are round numbers, that our grass needs about 1.5 inches of water per week, and that our shrub beds need about 1 inch of water per week. Round numbers, okay? It's, you know, it's just getting us close. So with our shrubs needing 1 inch of water per week, we're putting down 0.3 inches of water in an hour. How many hours a week do we need to run our system to apply what they need?
Just 4 hours.
A little over 3 hours.
3 hours.
A little over 30, yeah.
Yeah.
Okay. So then we'd set up our controller to irrigate, you know, a little over 3 hours. I mean, you could do the math.
Yeah.
A little over 3 hours a week, and you'd be fine. Okay? Does that make sense? Hang on. This is so hard. Yeah, okay, so do we understand? So now that we have 8.9 gallons a minute on this zone, okay, now we need to lay this out. So what are some other factors that we need to look at on that design guide to figure this out? One is the very next one that says maximum length of a single lateral on page 8. Okay. We went with a 0.4 emitter every 18 inches. And we're going to specify a 45-pound pressure regulator. What's our distance that we can go with that? 615 feet. Okay, is what that means is when we have our header and we put our header right here and we put our valve, filter, and pressure regulator right here, that we can run from this header 615 feet down to this header and we'll be fine. Okay, we're at 300, so we're fine. Correct? Now we know that our flow rate is at roughly 9 gallons a minute. If you go into your catalog towards the back, it shows on page number let's say we're going to use schedule pipe on page 69, and we don't want to exceed 5 feet per second. Do you remember those numbers? When we're designing our lateral lines, we don't want water flowing through our pipes at more than 5 feet per second. Have you guys done that yet? Okay. So what size of line does that header need to be to handle 9 gallons a minute and not exceed 5 feet per second. And I don't have my glasses on, so there's no way I can read that chart. I'm just going to say that you know it. What is that? What does that chart say? Are you going to make me look it up?
9 gallons a minute,
Yeah,
the 1-inch pipe.
a 1-inch pipe. Okay. So this header, okay, we're going to be putting this right here, right?
3/4 is really close, it's right on the
Okay, so I'll tell you right now,
5.4.
I'll tell you right now, most irrigation designers will use the 7.5 feet per second rule. Okay, so you could do 3/4 inch, which reduce the cost versus 1 inch. So basically, you're going to have one of these every 18 inches right along there to handle our zones along there. Okay, and we're going to have another one down on this end. Okay, and we're good. Do you have another question?
Yeah, I do. So you can go 600 feet. So, and this says single line.
Yeah.
This is one, but then we have it every 18 inches, so we'd have like
Yeah.
have
Yeah.
at
So
least 6 lines in there. Right?
yeah. So is what